Okay, good morning, everyone, and welcome to Biomass Canada Cluster webinar series. My name is Mahmoud Ebadian. I'm a research associate at the University of British Columbia, working on biomass, bioenergy, and biofuel supply chain and logistics. I'm part of two research groups at UBC, Biomass and Bioenergy Research Group, and Forest Products, Biotechnology, and Bioenergy. And as you know, we have been running this webinar series in the last 2 months, and you can find information about the past webinars, both the slide and recording of the past webinars on webinar page on Biomass Canada website. Also, you can find information about the future webinars. In total, there are 9 webinars, and each webinar focuses on one specific project that are part of Biomass Canada cluster. So you can find all of this information on the website, and still you can register for the future webinars if you're interested to participate. Just a quick overview of Biomass Canada cluster. It's led by BiofuelNet Canada network and with the financial support from Agriculture and Agri-Food Canada's Agri-Science program and also industry partners. The overall objective is to enhance the contribution of Canadian agriculture into the growing Canadian bioeconomy. As you know that compared to the woody biomass, we have commercial volumes on underutilized agricultural biomass that they can potentially contribute to the growth of bioeconomy in Canada. So that's the focus of this cluster. In total, there are 10 activities. Basically, there are 10 projects, and each of these projects are focusing on developing and also improving technologies for producing, processing, and also distributing feedstock from agricultural biomass for the production of low carbon intensive bioenergy, biofuels, and other bio-based products. Just a few housekeeping items. So this webinar is being recorded, and you can find a copy of recording and a slide after the presentation on the Biomass Canada website, as I mentioned before. Also, we have 2 boxes in this platform. So one of them is Q&A box, and I ask everyone to type your question in this box so we can answer as many questions as possible given the limited time we have for this webinar. And also, I encourage everyone to type your name and affiliation in the chat box, so at least we can get a sense of social networking in this platform. Okay, so today we have 4 quick presentations, and all of the presentations are from Biomass and Bioenergy Research Group. This is a research group at UBC that is leading one of the projects in Biomass Canada cluster. BBRG is a core group of engineers and scientists that they are focusing on turning raw biomass into industrial feedstock that could be used for different applications in the bioeconomy. And the main activities that BBRG has been focusing on are basically biomass pre-processing and logistics, such as biomass size reduction, dehydration, densification, and best practices for safe handling and storage of biomaterial. And also, we have been working on developing supply chain models, like mathematical models for conducting feedstock supply chain simulation and techno-economic analysis. And you see a list of partners, both government and industry partners, that they have been supporting R&D activities at BBRG. Okay, with that, I would like to introduce the first speaker. It's my pleasure to invite Dr. Shab Sukhansanj, he actually started Biomass and Bioenergy Research Group about 15 years ago, and he's still directing and leading the BBRG group, and he's a primary investigator for this project at Biomass Canada cluster. So Shab, please take it away.
Yes, thank you, Mahmoud. Good morning, everybody. And if you are in the afternoon, good afternoon as well. The project that I will be presenting to you and my colleagues will help us on this presentation is development of logistics, pre-treatment, and commercialization of agri pellets. This project is in partnership with Biomass Cluster Canada, as Mahmoud was mentioning, Biofuel Net, and the Wood Pellet Association of Canada. And the project is, of course, funded by Agriculture, Agri-Food Canada under the Canadian Agriculture Partnership. Next. Just give you a kind of make a case for this project. Between 2012 and 2018, the global wood pellet market has experienced growth rates averaging 11.6% annually, from about 19.5 million metric ton in 2012 to about 35.4 million metric tons in 2018. And as you may know, Canada is one of the major exporters of the product. It's about 4 million ton per year at the moment. The limited availability of sustainable forest biomass resources will increase the demand and global trade of other biomass resources such as agricultural residues. This is really true, especially with the new customers or people who want to use pellets like Japan that are looking into agricultural biomass as kind of added to the wood pellet. Despite the commercial production of agricultural biomass in Canada, in particular Canadian prairies, there is no use of agricultural biomass for bioenergy in Canada. The increase in the use of agricultural biomass requires converting a bulky and often high moisture ag biomass into dense products such as pellets with consistent quality. Next, Mahmoud. Pelletized biomass has several advantages over other forms of solid biomass for transport and storage. This really fits very well to the Canadian agricultural production and distribution system because of the long distances that we have in this country. So we have divided the projects into three programs or three tasks. One task is on looking at logistics of how moving pellets, especially agricultural pellets around. We work on quality, make sure that the material meet the quality standards, especially international standards. And also we spend quite a lot of research on storage of the material because, as you know, the seasons are short in Canada and we have to keep the material over the year. So with that, I will turn into one by one, logistics, quality, and storage. Mahmoud will explain the logistics work. Hamid will do on quality, and storage will be Fahime. Thank you.
Okay, thank you very much, Shahab, for the introduction. So as Shahab mentioned, that one of the tasks in this project is to identify a cost-efficient supply chain and logistic for agri pellets. So we have been looking at the different supply chain scenario, and we believe that one of the likely scenario for agri pellet is using mobile pellet units. And for the reason for that is we already have well-established grain supply chain in Canada. So if we can produce a product which has similar physical properties to grain, we can use the existing infrastructure we have for grain. And as you see on the top, farmers are already producing about 73 million tons of grain per year in Canada. And they're using on-farm storage to store them temporarily, and then they use truck to ship it to grain elevators. Then from that point on, grain elevator, they can ship product using rail to regional and international market by shipping them to the port terminals. And then from there, they load it onto ocean vessel going, and then they can reach international and also regional market. So if we can produce ag pellet at the early stage of supply chain, and I'm talking about the farm side, then basically we can use the same on-farm storage trucks and grain elevators to aggregate ag pellet from different farms, store it, and then depends on the location of the demand, we can either ship it to domestic markets, again, using truck or rails. And if there is a demand for ag pellet in the international market, then again, we can use the same rail cars that we are using for grain, ship it to like Port of Vancouver, Port of Prince Rupert, or like Thunder Bay, and then ship it to the international market. So that's basically the concept we are pursuing for ag pellet, again, using mobile pellet units. So in order to show these concepts, again, concept of mobile pellet unit, at the early stage of the project, we started contacting different farms in Canada who are interested to contribute to this project. So we have been in contact with a few farmers in Alberta and Saskatchewan, and currently we are working with one of the farmers in Deesbury, Alberta, Keith Cameron. And with his partners, he's operating about 7,500 acres of grain and hay, and also about 500 head of cow and calf operation. So basically, they are producing grain, hay, and also they have underutilized agricultural biomass that they are trying to basically find a market for that product. So in order to show the demonstration of this concept, BBRG recently purchased a mobile pellet unit from Sweden with a capacity of about 150 kilogram per hour. And this is a turnkey solution. So it means that it has all of the necessary operation, such as preconditioning, shredding, pelletization, cooling, and screening to produce ag pellet. And all of these operation units can fit into a 20-feet container. So it gives us opportunity and flexibility to move this equipment between farms and demonstrate the concept of mobile pellet unit in Canada. So this is still an ongoing process, and we are testing this equipment at the UBC, and then hopefully sometime in early spring, we are planning to send this equipment to Alberta. In addition to this unit we purchased, we also contacted different companies in the US, Europe, China, and India, and we have been trying to collect technical and economical data from different manufacturers. And you see a picture of some of these equipment. They are actually already in the market, and they have been developed for both woody and agricultural biomass. So we have collected some of the data from these manufacturers. So, and we are trying to understand the economics of this equipment, so to see how much it's going to cost to produce ag pellets. In an ideal case, a mobile pellet unit should have a low capital cost and high throughput. But at the moment, the existing manufacturers, the data we have, it shows that relative to other farm equipment, these mobile pellet unit, they have higher capital costs and low throughput. So in order to reduce the cost of ag pellet production, the annual use has a huge impact. So the more you use it in a year, the low you can have the ag pellets at the farm site. So that's what we have been trying to figure out, how the annual use of mobile pellet unit has an impact on the cost of ag pellets at the farm site. So we have run different scenarios. You see that we have been trying to understand the impact of annual use on the cost of ag pellet. And keep in mind that this is only the cost of ag pellet, not the raw material. So at the moment that we excluded that cost here. So you see that depends on the size of ag pellet. It could be from 5 to 4 tons per hour. We also look at the 1 to 2 tons per hour, and also a small size like half a ton per hour. So you see that with the increase of annual use, you can, from let's say 2,000 to 8,000 hours per year, you can reduce the ag pellet production cost by 60%. And also the higher capacity of the mobile pellet unit, the lower cost for ag pellet is going to be. So basically this graph is showing that. And also, if you break down the cost of ag pellet to capital costs and operating costs, this is again for those 3 scenarios I mentioned, again for large size and also a small size mobile pellet unit. You see that 30% is capital cost and about 70% is operating cost, which is the sum of energy costs, such as electricity or diesel, also the repair and maintenance and labor. So the message here is that if depends on the location of the mobile pellet unit, if you have access to the low energy costs and also labor, then you can also reduce your costs of ag pellet at the farm site. So some of the main conclusion, again, the use of mobile pellet unit year-round is very critical to produce ag pellet at a competitive cost. And also estimation for the cost of ag pellet at the farm site using different mobile pellet unit for 8,000 hours per year is quite competitive with the woody biomass. So you see that the cost was about 32 to 79 per ton, depends on the size of the mobile pellet unit. And if you compare that number with the cost of actual wood pellet in the existing pellet facilities in Canada, which is in the range of 45 to 65, you see that the cost of ag pellets used in mobile unit could be actually competitive with wood pellet. And also, this is the last comment I mentioned before, is that, again, since the majority of the cost is associated with energy costs and labor, the location of the mobile pellet unit operation also has an impact on the cost of ag pellet. So with that, I finish my presentation, and then I ask my colleague, Dr. Amrizai, to talk about the collecting ag pellet production data, which is task 1 in this project.
Okay, hello everyone. Thank you, Mahmoud and Dr. Shah, for your introduction and presentation. My name is Hamid. I'm working on one of the tasks in this project, which is about collecting agri-pellet production data. So today I want to present a little bit of our progress and the next step that we're going to do in testing the agricultural samples. Agricultural residues have very specific properties that are, kind of cloud-shaped fibers that retain in the grinder screen and stops the process. So you see the picture of the structure of this fiber that is stuck in the grinder in our test.
Go to the next, yeah.
Okay. We purchased one XRF unit that enables us to measure the mineral elements of biomass. The key elements that we are looking for in this project are chlorine, silica, potassium. Mineral content is a very critical property to show that the biomass potential for power generation application. Mineral elements form salts and are corrosive. We did a significant number of measurements to develop a standard operating procedure for mineral measurement of biomass material, and we're currently doing the main measurements on the received samples. Next, please, Mahmoud. Oh, sorry. I think would you please go to the next slide? We tested a demineralization process on the woody biomass with very high chlorine content. We showed that washing and then pressing is a very efficient method to wash some of the minerals out of the biomass. This method is very efficient to eliminate minerals that their sources are environmental dirt. The picture in this slide shows that how washing reduced the chlorine concentration in the material. We started testing the efficiency of the same washing and pressing process on agricultural residues. Next slide, please. For doing our pelletization test, we purchased, as Mahmoud explained, a PP100 unit from Sweden with a nominal capacity of 150 kg per hour. This unit has two advantages compared to other pellet machines in the labs. That this machine has all components of an industrial pelletization process. It has a mixer, feedstock mixer, it has a grinder, it has a conditioner, it has a pellet press, and also finally a cooler. Another advantage is that this unit is mobile, so the whole unit is assembled in one container, and we can transport it to the farm sites to test the concept of custom mobile pelletization in farms. And as the last slide, as our future actions, we are going to test various size reduction scenarios and propose and design an efficient size reduction approach for agricultural residues. We will test the efficiency of washing and pressing of agricultural residues to wash the minerals out of the biomass. We will test the effect of steam conditioning as a potential method to reduce the variability before the pelletization process. And also we will optimize the pellet production using the pilot scale pellet mill that we purchased recently. Thank you so much. So the next, Fahim is going to present on the storage, the safe storage and handling of biomass. Thank you.
Hello, can you guys hear me?
Yes.
Okay, thanks, Hamid. Thanks, Mahmoud. Thanks, Shahab. So as Shahab and Mahmoud and Hamid explained, there are 3 different tasks within this project, and task 3 that I will be talking about is specifically focused on the quality of the fuel throughout the supply chain and its compliance with the international standards. So for biomass, and in particular agricultural biomass, storage is a critical factor because the seasons are really short. So the quality of the biomass is subject to a lot of variation depending on where your agricultural biomass is coming from, what is the origin, what is the moisture content, what is the size, what is the shape, is it in pelletized form, is it bale, etc., etc. And depending on all of those, there could be different problems that could occur during handling and safe and storage of biomass. But the 2 that I would say are the most important to take into account and watch for are the self-heating and off-gassing, and as a result of off-gassing, oxygen depletion. So self-heating of biomass, and in particular, in this case, agricultural biomass could occur due to chemical reactions, or it could be due to microbial decay, or it could also happen due to physical processes. And in terms of physical processes, we are looking at the water uptake, whether in liquid form or in water vapor form. So if your biomass is really fresh, then there is really higher risk of self-heating and spontaneous combustion. Also, agricultural biomass, they releases CO, CO2, and methane, and they consume the oxygen around them in the environment. So carbon monoxide and carbon dioxide are odorless, and even though the concentration might be low, they could be lethal. So we have learned from our experience with the wood pellet industry that off-gassing and self-heating, they could both lead to really serious accidental fires as well as dangers for workers. So it's really important to look into these 2 during storage of biomass. Next slide, please. So what do we mean? Could you go back for a second, Mahmoud? So for this project and in this task, we would be particularly looking at the reactivity of the material, and we would be measuring the gas composition for during storage of agricultural material. And if you go next, please, I'll explain what do we really mean by reactivity. So what does it really mean? So the reactivity really represents the amount of heat that is coming off the material during storage. To evaluate the potential of self-heating for agricultural pellets, we use the isocalorimetry technique. So it can really record and measure the heat that is coming off the material during different storage conditions. And this heat could be due to biological processes, it could be due to chemical processes or physical processes. So the heat that is recorded could actually be the contribution of different components, but by changing the experimental condition and limiting those parameters, we are able to find the individual contributors. So as you can see on the left side, this is the type of the data that we receive from the equipment. So we look at the heat coming off the material during storage, and this storage time, depending on what is of our interest, could be hours, could be days, could be weeks of storage. So we measure the heat, the rate of heat transfer over time. And then this is the type of information that we get, and depending on how much heat is coming off the material, we would evaluate if this material is really reactive and so unstable, or if it's really stable and safe during storage. The advantage of this type of method is that it's really, it's not destructive. So we don't really do anything to the biomass, and we don't do any pre-treatment, or we don't destruct the structure of biomass. We include it, we put it in small storages, and then we put it in the machine, and we continuously and directly measure the heat coming off the material at different conditions. So there's really little experience with the off-gassing and self-heating of agricultural pellets. And so this will really help us to look at and evaluate the behavior of agricultural material during storage. So if you look at the graph in the middle of the slide, with the ones that are showing least stable and most stable. So if a material is really giving off a lot of heat, that would be really the least stable material. So that's how we categorize the agricultural material that we are evaluating. Next, please. So we measure the heat of agricultural residue pellets, or in other words, the reactivity from specifically 3 different reactions that we're looking at. One is the chemical reactions, and we look at the oxidation of the material. Then the second, we look at the water uptake in form of liquid. And third, we look at the vapor absorption. And for that, we put the material in different humidity and measure the heat coming off the material. So the amount of heat is really associated with the specific quality of that agricultural material, as well as the age. So as you can see on the right side picture, we store these little ampules. We store the different agricultural material in these ampules, and we really create that storage condition that we want to study within those ampules. We change the humidity within those ampules. We change the storage temperature. We change the concentration of oxygen, and anything really that we want to study, we create that condition within those ampules, and then we read the heat coming off the material. And if your material is really fresh, the biomass, so the heat of oxidation would be higher. But the other things that particularly of our interest for us in this study are the heat of vapor absorption, as well as the heat of water uptake. Next, please. Okay, so the 2 graphs here are really to kind of represent what type of information we get from this analytical equipment. On the left side, you can see where we stored, for example, here it was switchgrass. We stored it at 20 degrees. And then we exposed it to 2 different conditions. The first one was we were looking at the heat of oxidation. And for that, we just put it in those ampules. And in normal condition storage at 20 degrees, we stored it in the TAM unit. The other one, though, was where we exposed the material to liquid water drops. And then we wanted to measure the heat coming off the material. And for that, you can see on the left side, the huge peak coming off the material. So if you compare that heat with the heat of oxidation, you can see the heat of oxidation was really minimal. However, the heat of water uptake was about at 20 degrees, it was about 35 joule per gram. And then going to the right side graph, you can see that we exposed the material, the exact same material, we exposed it to different humidity. We increased the humidity from 50 to 85% over time. And then we stored the switchgrass at 2 different temperatures, 20 degrees and 40 degrees. So when we stored it at 20 degrees, there were less heat coming off the material compared to water absorption. It was about 16 joule per gram. But if you look at the temperature, when we increased the temperature from 20 to 40, the difference was significant. The heat coming off the material went all the way to about 95 joule per gram, which is almost 6 times as the same heat coming off at 20 degrees. So you do see that temperature is really key, and measuring all these parameters and the effect on the storage of agricultural material is really key. We need to understand all of these before we can really come up with safe storage guidelines for agricultural material. Next, please. Another factor to watch for during storage of agricultural material is off-gassing and oxygen depletion. So emission of carbon monoxide, carbon dioxide, and methane, and the depletion of oxygen within the storage of agricultural material needs to be evaluated. So our experience with woody biomass, it shows that if your temperature is really high and if your moisture content is really high, or there is a lot of humidity within the environment, you're going to have hydrogen also emitted. So which makes the environment really even more dangerous. So that's also something to look for, to watch for and measure. So our experience with the off-gassing shows that we're going to have to look at the depletion of oxygen over time and measure the rate of depletion of oxygen as well as emission of all of these gases. The ISO standards 248 part 2 is in fact a standard that was developed at the University of British Columbia at BBRG. And that method is the one that we are going to use for measuring the off-gassing rate from agricultural material. And it measures the concentration of gases from material in a closed container. Next, please. So why are we doing all of this really? And why does it matter what do we mean really by quality compliance? So these standards are really needed to be placed to make sure that the fuel is safe, first of all, and to make sure that the feedstock and fuel meet their needs. And the third thing is that they do facilitate the trade. So as an example, to show you what do we mean by facilitating the trade, an example comes from the wood pellet industry. The standards are really intended to make sure that the Canadian producers that produce the pellets and deliver pellets to customers, they will have consistent laboratory reading. And then these developed standards really give confidence, first of all, to the customer, to the supplier, and to the regulators. It's also critical for the producers of these type of material to be part of this standard development, because depending on specific conditions and specific situations, for example, for the case of wood pellets, we are shipping them overseas for long term. So it's really important to take that into account. For the agricultural pellets, though, the seasons are really short and storage is really important. So we're going to have to look at the safe storage of agricultural biomass, and it's key to look at those standards as well. So ISO Technical Committee 238, which is focused on solid biofuels, they have different working groups that they work on different aspects of solid biofuel, including agricultural material. So they do develop standards for different types of solid biofuel. And for example, the forestry, they have been part of this ISO Technical Committee for years. But for wood pellet industry, although they have been part of it for 10 years, but compared to a few other industries, they are kind of still new. And for the agricultural pellets, the way we see it, the journey has to be the same for agricultural pellets. So they could, in order to simplify really the communication between fuel suppliers and customers, or in other words, we have to really provide the market with the tools to determine the economic value of this solid fuel. Next, please. So what is coming up next? We will be first looking at, as a part of this project, in the task 3, we will be looking at the development of pretreatment methods. As Hamid mentioned, there are challenges with the quality of the agricultural materials. So we're looking at pretreatment methods to make sure they do comply with international standards. Second, we are looking at best practices for storage and handling of agricultural materials, so we can look at the degradation of the agricultural material and come up with guidelines and standards, international standards for safe storage and handling of agricultural pellets. And third, we will be also looking at the reactivity of the material in freezing and thawing condition, just to evaluate it for the Canadian climate. Next, please. I also wanted to quickly refer to this video that we produced as a part of the knowledge translation, and we produced it with the other industrial players. This video on best practices in managing combustible gas is really shows you how and where these gases accumulate during pelletization process, and it's applicable to woody, agriculture, and any types of biomass. So it really gives recommendations to reduce the risks, and I really ask everyone if you have the time to watch that video. And I've included a link under that image on this slide. And when they share the slides, that you should be able to watch it. Next, please. Thanks very much. I also want to thank Dr. Dawn Smith and Dr. Xiaoming Zhu in particular, and we are happy to take on any questions. Over to you, Mahmoud.
Okay, thank you very much, Fahima, Hamid, and Shahab. So first, I'd really like to apologize for my internet connection. It created a bunch of problems, but both in terms of the slides. I saw that some comments regarding that the slides and my discussion were not matching. I guess I was one slide behind, and also you see a yellow box. That's basically my computer problem. So I really apologize for that. So I think we have done a good job for presentation, and still we have 20 minutes left. So we have enough time for lots of questions and also discussion. So we have one question from Jay. He's asking, are there any plans to expand your work to other crop residues? For example, given the huge volume of canola grown on Canadian prairies, have you considered analyzing canola residue? Shab, do you want to take that question?
Yes, in fact, we are testing canola stalks at the moment, looking at that as a potential feedstock, especially with the steam treatment, as Hamid mentioned, that one of the things that we're doing is using techniques that we can minimize the variability among different parts of the plant, as well as between different species. And we think, and some research indicates that steam treatment might reduce this variability among different components. So we are including canola straw as one of the material that we are focusing on. The project, as you was mentioned here, and I hope that you sense from it, is really two-part. One is doing a lot of fundamental in the lab research to understand the properties of material, such as the work, for example, Fahima was mentioning. And there is another part of the project which is basically working with farmers at the farm level, show them the technology and see what is really the practical barriers. And that's the part that Mahmoud was explaining, So it's really is a span over not only different crops, but also different scales of the operation.
Okay, thank you, Shahab. So I can ask a question from Shahab and Fahima. You have been working with Wood Pellet Association of Canada for a long time. Do you see any interest from wood pellet producer in Canada to consider ag pellet as the supplement to the wood pellet they are producing in the future?
Fahima, you go first.
So yes, we do see a lot of interest from the pellet producers for supporting agricultural biomass. But as I mentioned in my presentation, there is still a number of challenges that we have to overcome. And once we have those ones underway, and we have kind of addressed those, and those material are we can use them with different types of boilers. There is no problem with corrosion, or we can address all of these problems, then yes, there is for sure uptake for agricultural biomass as a pelletization, but we have to make sure they comply with the standards, and that's what has really made the wood pellet industry successful, to address all those safety issues and property issues and performance issues. Once we do our homework there, then for sure there's uptake in the wood pellet industry.
I can add to that a bit, Mahmoud. Wood pellet, first, before I start that, I should say that Fahima has two hats. One is research associate on this project. The other one, she's a director of research and development at Wood Pellet Association of Canada. And so she's quite, that's where really our close connection with the industry goes, and has enabled us to basically reach out to the industry and work with them. But just want to mention on the question, Mahmoud, that you brought up. First, we're really learning a lot from how to make pellets from woody material. The problem, and it's not the problem, but the challenge at the moment is really a lot of sustainability issues and other issues that are associated with wood pellets that makes agricultural pellets more and becoming more and more, from a sustainability point of view, more attractive. As you know, we have been approached by major power producers like Drax in England that they want to look into biomass from agricultural material in a more serious way. And I think the idea that we have basically doing this on the farm level on a mobile system in a custom rate operation, similar to a harvesting operation, we are kind of embarking on this thing. Hopefully it goes forward as we are trying to get these issues solved.
Okay, thank you, Shahab. A couple of more questions. I see that they are popping up. So a question for Fahima. Will reactivity or heat flow results of biomass storage be affected by biomass or pellets density?
So we measure the heat we measure the heat, as I mentioned in my graphs, it's joule per gram. So we measure it really per unit mass of material. So the density doesn't matter, but what matters, what has made your pellet more dense? Is it more compaction, or is it higher temperature during the process, or what has really made it more dense? That, yes, makes an effect. Whatever, like different parameters that makes the difference in reactivity of material is the process condition that the material has gone through. So whether it's temperature, it's humidity, it's higher compaction, whatever that has gone through, but we will be measuring the reactivity as a joule per unit mass of material. So the density wouldn't really matter, but what has made that density higher would matter for sure.
Okay, I guess a similar question is for Fahima. What might be safety and performance issues to consider with storing biomass for fiber applications?
For what applications?
Fiber applications.
Oh, so it's still for the 4 materials that we have tested and evaluated, it's still early stages, and we can't make conclusive, make conclusions really, but I would say we do see the humidity and water absorption heat being an issue, and then we're kind of evaluating and ranking different types of agricultural material to see which one is most stable, which one's least stable, and we do see some really interesting differences there. Yes, self-heating and oxygen depletion and off-gassing are going to be, again, issues, and we are going to have to address them the way that we have addressed them for the wood pellet industry.
Okay, thank you, Fahima. This question for Shahab or Hamid. Does one ag feedstock appear more promising for pellet production than another?
Say it again.
I guess the question is about the quality. That does one ag feedstock appear more promising for pellet production than other feedstock?
Well, you know, most of the agricultural material are similar to each other in terms of pelletability. They do not have that much lignin content as, for example, woody material has, that provide the binding capability. Generally speaking, grassy material might be better in terms of like switchgrass, for example, or the ones that they have some, other, like some pectins or some protein, kind of that material, like, we work a lot on alfalfa type material. They make nice pellets. So really depends upon the composition of the material and how that composition play out in making pellets. Grass pellets, wheat pellets has been made but with the assistance of binders, starch and other kind of binders have been used in order to make durable pellets. And that's one area, as I mentioned, Dr. Lope Tabil at University of Saskatchewan under the SEAM program has done quite a bit of work on mixing woody material with agricultural material to increase the binding capability. So there is strategies that we can look into, see how we can improve the durability of the material.
Okay, thank you, Shahab. A question probably for Hamid or Faima. How the energy density of the ag pellet compared to wood pellets?
Hamid, this is right up your alley. You're muted.
Okay. Regarding the energy density, it's a little bit lower than wood, but as Dr. Shahab said, this is not the main challenge of the process. The main challenge is size reduction and having a good binding in the pellet. Regarding the heating value, it might be something in the range of 10 to 15% difference, but that is not the main challenge of the process.
Okay.
Just one comment. If I want to give you a very rough range, is kind of in the range of between 15 to 17 megajoule per kilogram for at least the ag samples that we are testing now.
Okay. Thank you, Hamid. So another question and comment. The University of Saskatchewan was doing torrefaction on oat hulls prior to processing. Mm-hmm. Were there any studies on storage stability with this type of pretreatment versus the results you are seeing in the tests you are conducting?
I can take that. So for torrefied material, we have looked a lot at the storage of woody torrefied material, but for agricultural material, we haven't done any reactivity testing or off-gassing testing yet. But we, as Shahab mentioned, we are collaborating with different PIs within this Biomass Canada cluster, and we are hoping to be able to look at those torrefied material too. But for woody biomass, yes, we've looked at a number of torrefied woody biomass that has been produced by different companies or different universities and looked at the storage in terms of off-gassing, self-heating, and compared them really. But for agricultural material, we're not there yet.
Okay, thank you, Faima. So I'd like to ask a question from Shahab. We talk about demonstration of a mobile pellet unit in Alberta. Shahab, if you want to make this like a routine process in farm communities, what do you think there is going to be the barriers and challenges to adopt this practice in farm communities in Canada?
Well, to me, the biggest challenge is really to demonstrate the project, the feasibility of this to the farmers, that this can be done. Pelletization is not a given. You can't really put a pellet unit in a farm and ask the farmer to make pellets. Pelletization is at the moment really is an art. You have to have a lot of experience how to run pellet unit, how to adjust temperature, moisture, particle size, all of the properties of material that make good pellets, and this requires experience. That's why we are advocating mobile pelletization. Mobile in terms of so the person or persons that run that mobile unit basically are very much familiar with the pellet equipment, so they can take it there and they basically take the farmer's bales, grind it up into pellets. Without farmer has to really learn the process of pelletization. This is really a key point that we have to work on it to sort of detach the pelletization itself from a farming operation in that sense, yet to integrate that with farming practices such as I said, custom harvesting. So the farmer calls a mobile pelletizer to his farm, to do the work, and then that goes to the next and next and next. Because of the, as you showed, Mahmoud, the initial cost of the pelletization equipment so high, so really you don't want a farmer buy a unit. And we're really advocating small scale, not large scale at the moment.
Okay, thank you, Shah.
Yeah, no.
And if I want to build on that question, Shah, because again, you have been in this area for a long time. So we talk about the integration of ag pellet with grain supply chain in Canada. What about the integration of ag pellet with the existing wood pellet industry we have in Canada? Do you see any potential integration like blending or any other ways that we can integrate wood pellet industry with the ag pellet in the future?
Yes, but as you know, wood pellet industry has evolved into 100,000 tons, 200,000 ton, 300,000 ton kind of capacity. And number one. Number two, as Fahimi mentioned, there is very precise international standards that they are basically following in order to make that pellets to that standard. And number three, at the moment, most of the pellets that are made in Canada and exported are on contractual basis. These are future deliverables under specific condition. Not much are in a spot market, like for heating application that might in Europe. So I don't see a whole lot at the moment that you bring agricultural material and mix up with woody material. I don't see it, but maybe happen, but those are the type. My feeling is that really we have to develop agricultural biomass pelletization as a kind of, independent. However, as you know, Wood Pellet Association of Canada is actually partner in this project, and they are supporting this project, but it's not to the point of taking the material inside the plant.
Okay. Thank you.
I don't know, Fahime, you may have some ideas.
No, right on, Shahab. Like at the moment, I'm not sure there is how much opportunity, but down the road, I do see possible opportunities for agricultural biomass to be integrated with wood pellet industry. And I should also mention that although we still don't have the domestic market for wood pellets, but we are definitely working on this and advocating for heating market, and with the clean fuel standards in place, and there's a lot of ways that we could replace different fossil fuels with wood pellets in Canada. And so we are able to meet our 2030 and 2050 GHG mandates. So there is a lot of opportunity there, and we are working on domestic market as well.
Thank you, Fahima. Well, actually, you mentioned domestic market. We had a question from Beryl Goosen. He actually contacted me before. He's a farmer in Saskatchewan, and he's asking how much of a domestic market do you see for these pellets, basically in Canada. Shah, do you want to add anything on that, on the potential domestic market for ag pellet?
Yeah, well, as you know, there is a study done by Jamie Stephan for Wood Pellet Association of Canada that there is a huge there is a market for agricultural pellets and pellets generally speaking in Saskatchewan, in Manitoba, in Nova Scotia, in parts of Quebec, and part of Alberta. So especially in Saskatchewan, as you know, there is really little biomass is used for heating purposes. Manitoba does some, on baled straw and things like that. So there is a market, and we really highly recommend that Saskatchewan develop some kind of policies where they, basically use these huge resources that is there for heating, at least heating at this point. And then later maybe for power production.
Okay, thank you, Shah. Another question from Saskatchewan, Mark Cooper. He's saying that the lack of local biomass power generation on the prairies also serves as a limiter on getting the ag pellet industry moving quickly. Do you see any opportunities for this to change in the coming years?
Who you want?
Well, I can
Yeah,
start.
you go ahead. You go
Yeah.
ahead.
So yeah, but definitely, as Shah mentioned, that we need supporting policy because competing with cheap electricity and natural gas is going to be challenging. So, but as you know, that Canadian government has plan in place, both for 2030, as Fahima mentioned that, and also 2050. So depends on the type of supporting policy. I guess there might be opportunity in the near future for use of ag pellet in Canada. But again, in a business as usual, definitely competing with natural gas and electricity for heat and power generation is going to be a huge challenge for not only ag pellet, even woody biomass to penetrate into the power and also heat generation in Canada.
Yeah, Mark, in Europe, wherever, like in Denmark, they have policy, or Sweden, and that really has helped agricultural pellet industry to go forward. So without the policy in place, I don't think we really have to encourage the politicians, basically support these concepts that you have, and hopefully, it goes forward.
Yeah. And another quick point I want to add to the Mark question and comments. Like personally, I believe that the focus at the moment is only on reducing the greenhouse gas emission. And unfortunately, we are not seeing any support from the government in terms of creating jobs. I mean, they talk about it, but we don't have a solid approach. So I guess we need a policy that supports both reducing emission and also creating the job at the local communities. And for ag biomass, we have a very solid argument that if you can reuse, collect, store, and handle agriculture biomass, that creates a lot of job at the local communities. And we have seen that actually in the wood pellet industry, like many of the harvest and also transportation company for wood pellet are actually companies in the local communities. And they have been able to survive and grow with the growth of wood pellet industry in Canada. So definitely there is such opportunity for ag pellet in Canada. But again, we don't have such a support in terms of policy in Canada for using ag pellet for bioenergy production. There is another question from Maria. She's asking about grain drying. I guess Shabis, you're the best answer this question. Opportunities for using ag pellets here, like using grain drying to dry ag biomass and then produce ag pellet.
That is really the good question, and one of the areas that has been done some work is basically make pellets at a higher moisture content and use grain dryers to dry those pellets which has high moisture. And this work was done at Idaho National Lab. Actually, one of our postdoctoral doing that in there. So it is possible, Maria. So we hope that we make pellets, and that pellets could be used not only be dried, but also help to supply heat if there is a drying is required.
Okay. Thank you very much. We already, I guess we reached the time. It's 12 p.m. Eastern time. I really, really appreciate all of the attendees to attend, taking the time and ask a lot of good questions. And hopefully we see you in the next webinar in 2 weeks. Thank you very much and have a good day.
Thank you.
Thank you.
Thank you.